In the cold, far reaches of our solar system, an ancient giant awakens. It's a story that began billions of years ago, and now, in a twist of cosmic irony, tiny, seemingly insignificant Pluto has become the subject of one of the most intense astronomical debates of our time. Prominent scientists such as Neil deGrasse Tyson and Michio Kaku have sounded the alarm about a possible collision with Neptune, which will change the fate of our solar system and affect the planet. How did this international dance begin? What does it mean for us? And could we be about to witness one of the worst events in world history? Once considered the ninth planet in the solar system, Pluto was demoted to a dwarf planet in 2006 by the International Astronomical Union, IAU. This classification is based on its unique orbit and small size compared to other planets. But despite the reduction, Pluto continues to fascinate astronomers and the general public in recent years. Predictions by prominent astrophysicists such as Neil deGrasse Tyson and Michio Kaku have caused serious concern about Pluto's orbit. These predictions point to a catastrophic collision with Neptune, which could have far-reaching consequences for the entire solar system, including Earth. But how did Pluto get this way? And what are the chances that this small and icy world will collide with one of our solar system's winds? Pluto's journey around the Sun is unlike any other planet. Pluto takes 248 years to complete one orbit, and since its discovery in 1930, it has not completed one orbit. The extremely long, icy nature of its orbit, which is 17 degrees from the plane of the ecliptic, the imaginary flat surface around which most of the planets revolve, adds to the mystery. This unusual path allows Pluto to cross Neptune's path. For 20 years in each orbit, Pluto moves closer to the Sun than Neptune, defying expectations based on their position in the solar system. This transition raises the stakes in a high-stakes space game, a game with potentially dangerous consequences. When Pluto crosses Neptune's path, the force of gravity between these two celestial bodies becomes a key factor in determining their future. Over time, these interactions have changed, adding layers of complexity to a complex situation. The dance between Pluto and Neptune shows the dynamics of our solar system. Although Pluto was seen as a lonely outlier in the outer regions, its close encounter with Neptune shows the interconnectedness of all celestial bodies. Each person sends out subtle arcs that shape the paths of the others, creating a delicate balance that, when disturbed, creates unimaginable chaos. Advances in observational technology allow astronomers to track Pluto's movements more precisely than ever before. This led to a better understanding of its orbit and possible implications for the stability of the outer solar system. Although the probability of a direct collision between Pluto and Neptune is low, it cannot be completely ruled out. The possibility of this phenomenon has led to continued monitoring and research by the astronomical community. The stakes are high, as even a small collision can send shock waves through the entire solar system. Given the complexity of Pluto's orbit, one wonders why a catastrophic collision between it and Neptune has not yet occurred. The answer lies in the gravitational forces at play at this time that prevented the two celestial bodies from colliding. Although Pluto's orbit varies, it is stable. Astronomers have identified various mechanisms that help maintain stability, such as a phenomenon called mean motion resonance. Of course, Pluto and Neptune are locked in a relationship that makes it impossible to achieve. However, the problem is not gone. The complex dance of gravity, orbital mechanics, and time is still conspiring to bring these two bodies into a deadly collision. The three-body problem is a concept in celestial mechanics that describes the complex gravitational interactions between three celestial bodies such as Pluto, Neptune, and the Sun. Solving this problem is particularly difficult because it involves predicting the motions of these objects based on their physical interactions, a difficult task due to the idiosyncratic nature of these processes. In the case of Pluto and Neptune, not only do their orbits affect each other, but the pull of the Sun. The result is a delicate balance that easily disturbs even the smallest things. Imagine for a moment that Pluto collides with Neptune. The energy from such a collision would be enormous, sending shock waves throughout the solar system. Fragments from this collision could hit other planets or moons, causing further damage. The rest of the shield that has held our solar system together for billions of years could be disrupted, with consequences that are difficult to predict. Even if it doesn't seem like it, it might still exist and scientists can't completely ignore it. This match can serve as a reminder of how fragile our world is. Neil deGrasse Tyson, a world-renowned astrologer, has discussed the dangers of Pluto's unusual orbit. He says that reclassifying Pluto as a dwarf planet is a step forward in our understanding of the solar system. However, he admits that Pluto's orbit is still a mystery and has yet to be solved. Tyson's colleague Michio Kaku has an interesting perspective on this topic. Known for his contributions to string theory, Kaku believes that studying phenomena like Pluto's orbit could provide valuable insights into the future of space exploration. He suggests that understanding the gravitational interactions and orbital dynamics of celestial bodies like Pluto could enhance future space missions and improve our ability to navigate the solar system safely. Kaku's interest in Pluto's orbit goes beyond mere curiosity. He believes that the gravitational forces at play in this cosmic dance could provide valuable data for testing predictions of string theory, a theoretical framework that seeks to describe the fundamental forces and matter in the universe. According to Kaku, a collision between Pluto and Neptune, while devastating in its immediate impact, could offer a unique observational opportunity. The force and frequency of the waves produced by such an event can explain the behavior of particles and fundamental forces under extreme conditions, essential to the study of string theory. Tyson and Kaku agree that studying Pluto's orbit is important for future space exploration. As we move further into space, understanding the complex interactions between celestial bodies is essential to planning safe and successful missions. Lessons learned from the orbit of Pluto can be applied to other celestial bodies and to planning for the exploration of distant worlds. By understanding the complex mechanics of the solar system, we can better prepare for the challenges ahead of us in exploring the universe. Despite advances in our understanding of celestial mechanics, the universe remains an uncertain place. The theory of orbital chaos, the idea that small changes in the position or speed of a celestial body lead to large changes in its orbital, reminds us that even the most stable systems can stay on time. Scientists use advanced simulations to model the interaction of celestial bodies such as Pluto with others in the solar system. These simulations show that what at first appears to be chaos may actually be a simple balance of forces. By studying these interactions, scientists hope to gain a deeper understanding of the universe and our place in it. Although there may not be a collision between Pluto and Neptune in our lifetime, the possibility remains. And as we deepen our knowledge of the universe, we become increasingly aware of the potential dangers lurking in the far reaches of our solar system. Pluto's orbit is a reminder that the universe is a dynamic and ever-changing place. The forces that govern the motion of celestial bodies are complex and often impossible to predict. As we continue to explore the world, we need to be alert and prepared for the unexpected. The potential collision between Pluto and Neptune is just one example of the many uncertainties in our universe. As scientists continue to study these phenomena, they are reminded of the fragile nature of the solar system and the delicate balance it maintains. The continued exploration of Pluto's orbit is an example of the continued pursuit of knowledge in space exploration. Each discovery brings us closer to understanding the complex nature of the universe, a journey that challenges our imaginations, broadens our horizons, and inspires generations of explorers and scientists. Looking to the future, the potential clash between Pluto and Neptune is a great reminder of how big and unpredictable the world is. It's a reminder that despite our best efforts, we still have the love of forces far away from us. But it's also a reminder of the power of vision in the world.